Hello guys, I am Udit and welcome back to my channel. Today in this video we are going to see how I design chess low level system design. So basically I actually got queries from people and I was also thinking personally also like chess is a very interesting problem for a low level design, and I started coding it myself, and I implemented some of the features of chess, and then I came up with this LLD, and I thought yeah, I should record the video on this and explain you my approach so that it can benefit you in your interviews. So as I said, in this problem we are going to see how I design chess, and we are talking about its low level system design. So we'll see how I implemented, how I created classes, how I implemented various OOPS principles, various design patterns and all, and how this design is very flexible and extensible, right? Just one request, since this is an LLD problem, and it has many aspects to it, like how did I design, what all design principles are included, how you can include or improve more changes into it, how you can satisfy for future requirements in this design. So just watch this video completely so that you get the complete idea of the full design of chess, right? Great. So let's go through the problem statement, as I've added over here in this repo also. In this problem statement, as it is a very simple problem statement where we just say, you have to design a simple chess game. There is nothing specific requirements given. It's just that you have to design a very simple chess game. The requirements are very open since it was not given to me by anyone. I myself started it, so I just you know kept the problem open, like any requirements or actually the actual rules that you have in the chess that has to be implemented by this design, right? Since chess is a very standard problem, so I thought about not going through its rules because that's just waste of time for all of us. So but I have just mentioned some entities, like chess has a board, a cell, a player, and a piece. Like board is the actual board. A board has multiple cells. So it's like a grid of cells. A player is like who is playing. A piece is something which you move on chessboard, right? So this is very basic entities of chess, and there are some rules. Like each piece has some rules, like how they can move and what all moves are allowed for that piece. So you can actually go through the rules of chess offline, and I would really encourage you to do that first if you are not aware about chess rules, so that you understand the design completely. Okay. Now, coming to the expectations, like what are the expectations required from this design? It's like first very much required expectation is like it should be functionally correct, which is I think very fair expectation. Like whatever you have written should work fine and should work correctly. Like it should follow the chess rules and it should satisfy the chess rules. So the code should be functionally correct. It should be modular and readable. So when someone is reading through the code, it should be self-explainable to the person, right? The readability of the code should be good. It should be clean, and the code should look professional, right? So all of these things improve, the way, or actually the readability of your code. Like if you have written clean, professional, modular code, it just improves the readability. So that's what expected from this code. It should be extensible and scalable. So if there are future requirements coming in, so your code or design should be able to accommodate that also with some minimal requirements, minimal changes actually, right? So that's the one of the most important requirements of any system design. Actually, the low level system design, that your classes should be designed in such a way so that if something new comes up tomorrow, minimal number of changes are required for, minimum number of changes we need to do to accommodate those future requirements. We'll touch upon that later on also in detail, but yeah, that's the basic idea. And then your code should have good OOPS design also. So you should implement some OOPS principles into your design. So yeah, let us see how I have designed it, what all classes I have created in my design, right? So let's start with the model. So I have already, as I told you, like chess has some basic entities. So I have also modeled them in the classes. So one basic entity is board. That's the first entity that I have created. It's like a board. It identifies the actual physical board that you have in chess. A board has two things. One, it's like board size, which is 8 by 8 by default in chess, but I have kept it flexible, so you can create a chessboard of any size. Then it has a grid of cells, right? So there is a 2D array for cells, and it in each cell type identifies a particular cell on the grid. We'll come to it in a bit when we discuss cell, but basically a board has a board size and a grid of cells. And the same things it takes in the input in the constructor. So a board takes a board size and it cells in it, initializes it. Then I created some helper methods for fetching the adjacent cells of a particular cell. So for example, if you are at a cell and you want to find the left cell of it, then you will just call the get left cell method. If you want a right cell of a particular cell, then you will call get right cell method. If you want an up cell, so you will call this method, and if you want down cell, then you will call this method. So these are the helper methods, where in a board, if you have a reference to a particular cell, then you can use these methods to get the adjacent cells. And then there's a method for fetching cell at a particular location. So you will give it x and y, and you will get the cell back for the particular location. And if the location that you give is out of the board, so if it is greater than, if it is greater than equals to board size, and if it's less than 0, then you will return null. So that means cell does not exist, right? Then there is a helper method which checks whether the which actually looks for whether the player is on check. So there is something called checkmate in chess, right? Check means your king is getting killed by someone. By someone is like by some piece of opponent's player, right? So that's what it is, identifying, or it is this particular method is giving the result as. So this method finds out whether uh, a particular player, a particular player's king is getting killed by the opponent or not, right? So that's actually what it is checking for. So there is a method called check if piece can be killed, and this particular method actually takes a target piece, like we have to check which piece we are checking for, and then it takes some evaluation blockers. We'll come to like evaluation blockers, what are they and why are they being introduced. And then there is some player. Okay, so we'll check, this method actually checks for whether this piece of this player is getting killed or not. And when we pass king over here, this actually means that we are checking whether the king of this player is getting killed or not, and that's the condition for check, right? So that's what it is looking for. There's one method to check whether a particular piece can be killed or not, which is being used by this method. And it just go through all the cells in the board, and finds the piece at each of the cells, and if the piece is from the opponent piece, then it finds out what are the next possible cells. So we'll come to it later on actually, because it uses some methods which will make more sense to you once we visit them. Okay, so it uses some logic to find out whether the piece can be killed or not, and we'll come to it. Next object I have created, or next class I have created, is cell. Cell is just a location on the grid. It's like a cell on the grid, and as I told you, board has a grid of cells. So a board has a grid and grid has cells. So there is a cell which has xy location, and each cell at any point of time can have a current piece. So when the cell started, the board will be empty, right? You just open the board, you just create the board. But when you start the game, you will put some pieces on some of the cells, and when as the game continues, the pieces will move from one cell to another. So the same way, there's a current piece for each of the cell, and there's a setter provided for it, so that you can change the current piece for it. So initially some cells will have it, some cells will not have it, and as we move some pieces, this will become null for the previous cells, and for the new cell which the piece moves to, that will become the value of that piece, right? Similarly, is free is the helper method, which is actually checking whether the cell is free or not, and that's getting identified by whether the cell is actually null or not, right? If the cell is null, sorry, if the current piece is null, then um, that means the cell is free. It has nothing, right? So that's how it is checking is free. Then there is something called color. So as you might already know, like chess, sorry, so chess has two types of pieces. One is black, one is white. So this color is actually identifying just that, black for black pieces, white for white pieces. Piece, let's come to it in a minute. So piece type is again an enum. Piece type is it's taking is actually identifying, is actually telling what are the different types of pieces supported in the game. So it's like queen, king, queen, rook, knight, bishop, pawn. It's just like an enum which identifies the type of piece, right? Then we have a player. Player has a pieces, and player has a method called get piece, and given a type, it will return you the specific piece of that type. It's an abstract class because a player can be of different types. For example, a player can be a network player, a player can be a local player, a player can be playing by a UI, it can be playing by a command line. So there can be many interfaces of how player makes a move. So because make move is a abstract it's coming out to be abstract thing, like each different types of player will have different type of move method. So that's why make move is being made abstract method, and each of the subclass, or the actual implementation of player will implement its specific move. But what a player will definitely have, it's a set of pieces, right? So we have given a template. It's like a template pattern. We'll come to the types of patterns the design is following later on, but yeah, that's what a player class is. Now let's see something interesting, which is which is going to help us understanding piece class more. So maybe we can just see what piece class has as properties. So piece class has a property like skilled. It just tells whether the piece is skilled or not. It has one color, right? It has move providers. We'll come to it. It has like num moves, it identifies how many moves the piece has done, and it has a piece type, and it has a current cell. So its piece can also move from one cell to another, so we are just keeping track of what is the current cell at which the piece is currently presented. Then we have a constructor. A constructor is having color, move providers, and piece type. It just initializes the piece. Now let's before going further, because piece has like move and next possible cells methods, so let's first understand some conditions and move providers so that you understand the move method better. So let's see what's conditions tell. Okay, so move base condition tells that it actually provides you a base condition for a piece to make a move. So for example, let's say there's a piece called pawn, right? And pawn have two different types of mechanisms. One is like it can actually make one move forward, and another mechanism is, or another rule that it allows is कि, pawn can make two moves only if it is its first move, right? So that's like a base condition. Like there are two types of moves possible for pawn. One is vertical move with one step anytime, and with vertical move with two steps, but only in the beginning. So that beginning thing is identified by this base condition. So each type of move, like a vertical move that we're saying, will be having a base condition. Okay, and we'll see when once we go to the move providers how this base condition is getting staged. But the base condition is actually telling you that like some condition which the piece, or actually the piece should fulfill, so that it can make that particular move. Okay, so for example, one base condition that we have for this is um, first move, right? Like as I said, for a pawn, the number of moves for that piece should be zero till now. So that's actually the base condition for pawn for two moves, right? So that's one condition. Second thing that I have defined is actually there is one more base condition is which is just for for all of the other pieces, like it always return true. This means there is no base condition associated with a move. Another thing which I have created is like cell occupy blocker. Um, Cell occupy blocker says that whether a particular piece can occupy a given cell in the board. So for example, piece is at a particular cell in the at a time, right? It just tells you whether the piece can move from that current cell or jump from that current cell to the destination cell that we have given. So it will take a cell and we will tell if the piece leaves its current cell and just reaches this cell, is that destination cell which we are getting over here is occupiable by the piece or not. This is what it is returning. So what does it mean is, so for example, if a piece wants to make a move from X cell to Y cell, right? So the Y cell has to be free, right? Otherwise the piece cannot move on that cell. And if it is occupied, then it has to be occupied by the opponent, because then it's a killing scenario. So if the destination cell is occupied by the piece which belongs to the same player, then it cannot occupy that cell, right? Because you cannot remove your own piece from the board. So that's all what it tells. Like it actually tells whether a particular cell can a piece occupy or not. So as you can see, like they it's actually implemented by two classes. One is self piece. So as I told you, a piece cannot occupy a cell if a cell already has a piece from the same player, right? um, um, so how does it check it? Like it just it has to return whether the cell is non-occupiable or not. So that means if the cell is free, that means it's occupiable, that means it's not non-occupiable, right? So that's why we are returning false from here. Similarly, cell will be non-occupiable, it will if it's of the same color, because same color identifies same players, right? So that's how we are checking whether a particular cell is non-occupiable by a piece or not. So that's one of the blocker condition for a piece to move to a particular cell. Another blocker condition which is there is it's a king check, right? If a king is getting a check by that move. So for example, if you have a rook and you have a king in behind it, and there is a another rook in front of it, right? So like opponent rook, your rook, and then king. So your rook is actually preventing check from the opponent's rook, right? So that actually means you cannot move your rook to any of the cells, right? That means you cannot occupy any of the different cells by leaving your current cell, right? So that's the whole idea of this particular blocker. So this blocker checks whether if current piece leaves its current cell and jumps to the new cell, will king get a check, right? Or king gets killed, right? So that's what it's checking for. It is saving the previous cell. It is moving the piece to the new cell, and then it is checking whether the player is on check or not. And once it has checked it, it is restoring the piece to the back to the cell. So by that way, it will check if the move is done from current cell to this cell, whether the piece or the player actually will get the check or not. Player's king will get the check or not. So if it's get a check, then we cannot make that move. So that's again one of the blockers. So we'll see how the blockers will be used, but I mean, I've just explained it so that when I use it, it will be easier for you. So there's something called cell occupy blockers, and cell occupy blocker will tell if a piece is not, if a cell is not occupiable or is blocked for piece to be occupied, right? A cell is blocked and it cannot be occupied by the piece, right? That's what we are saying. Then there is something called move further condition. So for example, if a cell has reached if a piece has reached some some cell, so can it move further from it? So that's what move further condition is actually telling, like if a piece can move further from a particular cell. So it's take a cell, it's take a piece, and it's take a board. One condition is like by default condition, like a cell can move from one piece to another only if it is at a current piece, right? You will understand it more once we once we go to the moves provider. But like if we have a rook and it has a 10 position, so we can move from 1 2 3 4 up to 10 only if all the cells are free in between, right? If any cell is occupied, then rook will have to stop over there. So that's what it is checking for. If the cell is free, then it will keep moving. You will see how it is being used over here in the moves provider, so we'll just go to that. So moves providers functionality is actually to tell, or to give all the next set of possible moves for a piece. So it's a abstract class which, given a piece and given a type of move, it will tell what are the available types of cells which the piece can move to. So for example, let's say if you have horizontal moves, right? So so horizontal type move provider will give you all the next cells which the piece can move to using horizontal moves. Similarly, there is a vertical move provider. Vertical move provider will tell how many cells or what all cells a piece can move to using vertical direction, right? Similarly, diagonal move provider will tell what all diagonally cells a piece can move to using diagonal direction. So if like for example, let's say queen. A queen can move in all the directions, so it will have all diagonal provider, horizontal provider, and vertical provider also. Like rook has only vertical or horizontal capabilities, so it will have two providers, horizontal and vertical providers. But this particular moves provider is specific type of move, like it's either vertical or horizontal or diagonal. So it's a one type of move, right? That's what single moves provider will be identifying. So we'll just see the details of it. So as you can see, moves provider is being implemented by three classes. One is diagonal, one is horizontal, and one is vertical. I have not implemented the move for knight, but yeah, that's something open. You guys can implement it later on. But I have implemented three types. One is a diagonal move type, a horizontal move type, and a vertical move type. Now, each move provider will take a base condition because, as I told you, a base condition tells whether the move is possible or not. So it's take a base condition. It takes move further condition because it has to find out from which all cells it can move further. So it takes a move further condition, and it takes a base blocker. Base blocker is like a blocker which a move will always have. There are two types of blockers in this design that we have used. One is base blocker and one is additional blocker. So base blocker applies to all the pieces which uses that move, and additional blockers are used by the piece as and when required for a particular move. Okay, so you will get the more clarity as we go through a design, but the space blocker is, as I told you, right, blocker is something which is telling you whether a piece can occupy a cell or not. So base blocker is, is telling like whether a piece can occupy a particular cell using this particular move or not. Okay, um, great. So now there is also called maximum steps. So for example, how many maximum steps a particular piece can move in a single move, right? So that's what maximum steps is telling. So for example, pawn can only make one move at a time, right? So maximum step will be one for it. King can make one, so maximum step for king for also will also be one. For others, like king, queen, rook, it's like unlimited. So maybe we can give 8 because that's the maximum board size, or whatever the board size we have, that we can give that number, or we can give some infinite number to the maximum steps. So that's how it is initialized. Then we have a method called possible moves. As I told you, this class actually this class actually tells you what all are the possible cells which this particular piece can move to using current type, right? So this method actually gives that. So it takes a piece, it takes a board, and it takes those additional blockers which I was telling you. Like, so for a particular move, if there are some additional blockers for that move, then you can give it over there, and then for a and the player who is playing, that is given. Okay, so this method actually returns the list of cells to which the particular player can move to, using this particular current type of move. Let's see how it is implemented. So first of all, we check whether the base condition is fulfilled or not. So whether the particular move is allowed at all or not, right? So base condition tells whether that is allowed or not. So we just give it a piece and we just check whether the base condition is fulfilled or not. If the base condition is not fulfilled, that means that particular move is not allowed at all. So you just return null from it, right? If the base condition is fulfilled, then you just do, you just find out all the possible moves for this current type, right? Whatever the current type is, you just find all the possible moves for that. So let's just see what are the what's this method. This method, as expected, it is an abstract method because possible moves for current type depends on the type of move, and that has to be implemented, or that has to be defined by the subclasses. So let's see one of them. Let's see horizontal. So horizontal possible moves actually, it just gives us the list of cells which are reachable by the piece using only horizontal moves. And horizontal moves can be of two types, like either left of the current piece or right of the current piece. Those are the only two horizontal moves possible. So we find all the next moves possible for the piece in the left direction. Okay, so this particular thing gives left cell of the current cell, and we just keep on moving from left, and until we and the point till we can reach that point, we just find all the cells and we return them. And this method helps us doing that. We'll go to that method in a bit, but this method actually takes a provider. So how does it work is like, it takes left provider, so that means it will go left from the current piece, and it will find all the cells until which we can go, and then it will return it. So it will be added to the result. Similarly for the right, we will go right, and we'll return all the available cells and we'll return to the result. So result will add all the left cells and as well as the right cells, and it will then return it. Now let's see how this all next moves is implemented. So all next moves, as I told you, like, it ask you cell provider, like left cell or right cell, like the next cell from the current cell, how do you move to the next cell, right? So like from left we provide left cell provider, for the right we provide right cell provider, right? So how does it work is like, you have a result, which you have to return at the end, and result actually holds all the list of cells which the piece can move to, using this particular cell provider, or using this particular direction. Actually, like, this is actually giving the next cell provider, right? So so you just find the first next cell, like the first cell which you can go to. So you just ask the next cell provider to find the next cell for the current cell where the piece is currently at, and since you have made one step, so you increase the number of steps by one. Now you check whether you are fulfilling these two conditions. These two conditions tells that the next cell should not be equals to null. This means that cell should be a valid cell and you should not have gone out of board. right? And the num steps condition tells that the number of steps that you are allowed to do maximum, that you are within that condition. So let's say for a rook or for a pawn, if you have already made one step, then you will come out of the loop because you are not no, you are not allowed to make more steps, right? um, so that's what it's checking for. Now once you have got the next cell, you have to check whether you can occupy that cell or not, right? Because not all cells are occupied. You have reached a cell, but you can have a self piece over there, piece from the same player over there, so you cannot occupy it. So that's why you just check whether the piece can be occupied or not. So to check the piece can be occupied or not, we have the check piece piece cell occupy blocker, right? So we use those two blockers as we discussed. So we have two blockers, one is base blocker and one is additional blocker. So we first check base blocker is not blocking us from occupying that cell. So if it is occupying, if it is blocking if it's blocking us from occupying that cell, so we return false, like the cell cannot be occupied. And if any additional blockers is also blocking us from occupying that cell, then also we return false. Okay, if none of the blockers are occupying us from the occupying that cell, then we return true. Okay, so that's how we check whether the particular cell can be occupied or not. And if the cell can be occupied, then we just add it to the result, and we are good. Now once we have occupied that cell, or, we have actually reached that cell, then we have to see whether we can move forward from that cell or not. So over there, actually move further condition will use. So as I was telling you, right, like you will understand it later on. So you have reached that cell, you are trying to find out all the possible cells, and in that hunt you have reached one particular cell. Now you have to see whether you can move further or not, right? So you can move further only when you until you land at free cells, right? So that's what move further condition is telling you. So you can only uh, move further only if the move further condition is fulfilled, right? So the move further condition right now is only the free one that we have implemented, so which is the default one in chess. So until you reach the free cells, in that sense, then you can move further until then, right? So if actually move further condition says that you cannot move, so that if there's a not, then you just break out of it. That means no further moves are possible. If you can move further, then you just find out the next cell and you increase the number of steps, right? So that's how all the next possible moves, or all the next possible cells which a piece can go to at a time in a particular type using a particular direction, right? That it returns. So for example, um, uh, how many cells or what all cells a queen can move to using horizontal direction, this particular thing will give. Or any piece will actually go to using horizontal direction, this particular class will give it. Actually the object will be of this class, but so this will give the next cells, right? Let's see vertical also. So for example, in vertical, you have one more thing which is like vertical direction. Like for example, pawns are allowed to move only forward. So for black pawns it will be up, sorry, for white pawns it will be up, and for black pawns it will be down, right? So we have added those vertical move direction. And so when creating moves for pawns, we will define the direction, and the pawns which have up direction allowed, we will add only up cells, and for the pawns which have only down direction allowed, we will add only down cells, right? And for this, and for the pieces which have both the directions, so for example queen, or rook, those can move vertically in both the directions, so you will get both, and you will add both up cell and down cells for the queen. Okay, so now we have seen how a single move type provider will work. Now let's see how a piece gets all the move type providers. So as you might already be getting the idea, a piece will have multiple move types provider, right? So for example, a queen will have horizontal also, vertical also, and diagonal also. A rook will have horizontal and vertical. Bishop will have vertical. Sorry, not vertical. It will be have diagonal, right? A king will have all of them, but it will it will have maximum step as one. So I have just created like pieces in the test file. So maybe if I just go through you go so show you those, just so that you get better idea. So for example, a pawn will have the pawn move providers will have two move verticals. One is maximum step as one, and one is maximum step as two, and the one is always available for the pawn, so you have no base condition for it. And the two is only available when the pawn is doing his first move, so there is a base condition available for it, right? And then we give the default move for the condition, which is the piece move for the condition default, which is like just checking for free, right? So that's how you define a pawn. And for the base blocker for the pawn, it's like just you should not have anything at the destination. So that's the default blocker. If you see, so we have a factory which is giving multiple types of copy blockers, cell blockers. So default blocker is like self piece, and there is additional blockers right now which is like king check, and I will show you why this additional blockers is having king check and not self piece. Self piece is anyways as a base blocker, right? So every move, every piece actually cannot occupy a cell if there is a self piece, so that actually qualifies for a base blocker that will be applicable for all of the moves. So that's why it's being given as base blocker. And since king check thing, whether piece can move if there is a check or not, that we need in some cases and we do not need in another other cases. So that's why we have put it in additional blockers, and I will show you where do we not need it. So for example, if you see, there is one more blockers list which we have created where we are not putting it, so that's where we are needing a list without this. So we'll come to it later on. But yeah, so you have a factory where you are creating base blockers, right? Like for different use cases. So for the default base blocker, you are just giving self piece, right? So that's where you're getting the default base blocker. So a piece will get a default base blocker, right? So pawn, so actually the move will get a default base blocker, and the pawn, and it will get a pawn direction, right? So pawn, for white it will be it will be up, and for blacks it will be down. So that's how we have created pawn. Similarly, if you see, the king when we are getting king, we have given it all the directions, like vertical, horizontal, and diagonal, and we have maximized it to one step. So like king can move in all the directions but only up to one step. Similarly for the queen, it can again move in all the directions but only up to 8 steps, because we have decided our board size to be 8, right? So in the test that we have created, we have decided the board size to be 8. Similarly for bishop, it's giving only diagonal, right? So similar, so that way different types of piece will have different types of combinations of move providers. So let's see how the move providers work in a piece. As you have already seen, we give multiple move providers for a single piece, like multiple pieces have different move providers. Now there's a method in this class which says next possible cells. This gives the next possible cells for a particular piece. So this means getting cells from all the move providers, right? So that's what it actually do. It just iterates through all the moves providers, and get cells from each of the moves providers, and if it's not null, then it will just add it to the result. Since different move providers can give duplicate cells, so we will just remove duplicates and we will return the results. So now once we have this method will give us what all different types of cells, or different number of cells, or different cells actually a particular piece can move to. So now if you related to a move, so when you have to move a particular piece, it's sort of straightforward now. You just find all the next possible cells, and if the two cell where you are trying to move the piece to, it's contained in the next possible cells, then it's a valid one. If it is not contained, then it is an invalid move, so you just throw an exception. If it is a valid move, you just, if there's a target, if there's a piece at the target cell, then you will just kill it, because you were allowed to move onto it only if it was not your piece, because there's a blocker on that, right? So if there's a piece on the target, that means it's of the opponent, so we'll just kill it, and you will occupy that cell, right? So to occupy that cell, you will leave your current cell. So current cell's piece becomes null. You change your current cell, so you move to that cell and you set yourself to be on that cell, so that cell's current piece becomes you, and then you increase the number of moves by 1. So that's how the move is working. Move is actually finding all the next possible cells which the current piece can move to, and that it is doing by using all the move providers that the piece is configured to use, and by finding all the next possible cells, it will just check whether the cell where we are trying to move is included in that or not. Okay, so that's how you are doing move. Now we have covered piece, we have covered piece type, we have covered almost everything. So there are just some exceptions which I have created for throwing whenever some conditions are not met. One thing we are still not covered is like board. So board, we had this method, right? Like we have to check whether a particular piece can be killed or not. So a piece can be killed, right? Like the target piece can be killed only if any of the opponent piece can move to this target piece, right, at any given board configuration, correct? So that's what we are checking for here. So we go through all the cells in the board, so and we find the piece at the current cell, and if there is a piece at the current cell, and if it is not from the same player that the target piece has. So it should be from the different player. That means we are looking for only the opponent pieces. So we find at this point we will get, actually not at this point, at this point we will get only the opponent pieces, right? In this if condition we'll have the opponent pieces. So now we have to check whether this opponent piece can kill this target piece or not, right? How do you find it? You will find it by checking out if the opponent piece's next possible cells include the location of this target cell, right? Target piece. So that's what we are doing here. We will find the piece, opponent piece, and you will find all the next possible cells for the opponent piece. And then if the next possible cells contain the target piece's cell, that means it can be killed. And that's where you will use, check occupy blockers, which I told you, like, empty blockers, because when you are checking whether piece can be killed or not, you cannot, you do not need, you actually, when you are actually checking whether the king is on check or not, you do not need to have this blocker, because that blocker is not valid at that time. So that's why we cannot use that blocker at that particular time when we are checking whether the king is on check or not. So as you can see over here, that's what we have done. When we are checking whether the king can be killed or not, we have not used that blocker, and that list gives empty list, right? So yeah, that's why we had defined this particular thing. Great. So I have covered almost everything. The only thing which is left is the game controller. So let's go through that also. The game controller is like a gameplay. So gameplay is like, it just runs forever until someone wins or someone loses. Then you have a current player over here, and current player is in the beginning it is zero. Like the first player is the current player, and the gameplay actually gets in the input a list of players and the board. So you will find the current player. So you will try to find it, and then you will try to ask the player to make a move. Player's move is an abstract method, so depending on type of player it will make a move, and it returns actually a player move contract, right? So there's a contract between us and the player. So player will have to return a piece, sorry, a player will, yeah, player will have to return a move, and the move will have a piece and the two cell. So that's what we actually need. Like, we have to move a piece to a particular cell, so that's what we get in a move. Then once we get that, we use that piece and we try to move the piece from that particular to that particular cell, right? And that's what we have implemented over here, as we saw, using the next move providers, right? um, Possible move providers, actually, yeah. Now then, once the move is done, we move to the next player. So that's the whole design of the low level chess. The next thing I have done is I have created a gameplay, a unit test which actually simulates a simple gameplay. So over there I have created a board. A board is a simple board, a size and a cell. Then we have then I have actually a I'm creating a pieces. So I have to, so basically what will a game have? A game will have a board, it will have pieces, and it will have players. So I have created board. Now I have to get pieces for black and white both. So I create pieces set for white. So a particular pieces set method will create all the pawns, all the kings, and it will put them on the board. So I have created pieces, and then I have created a player, and then then I'm ready with the so my game has started, or game has begun. The game is set up, actually. So now I print the board initially. Then then I just find the white queen, and I will find out from the board where's my white queen. It will return me the white queen. I will validate it's a white queen only, like it's white and queen. Then I will try to find out what all are the next possible moves for the, or next possible cells for the white queen, right? And initially, as you can understand, like, white queen is stuck because there are pawns in front of it, right? So when you try to find next possible cells, it should return empty in the beginning. Then what we try to do, we try to move a pawn in front of the queen. So we get the white pawn from the front of the queen, and then it should be a white pawn, and then we find out its possible moves. Since pawn can either make one move or two moves, since it's a beginning, so we get next possible cells as two, and we take second move, which actually is two move thing, two move cell, two step move at the second place. That's what it is at the second place. So that move I take, and I make the move for this white pawn. So I try to find the next possible cells for the white pawn. It returns two types of cells are possible for this pawn. I take the one with the two moves. Okay, I move it, then I print the board again after the two moves, and then I will return. I will check that the pawn has moved or not. It should have moved. Now I tried to find out the next possible moves for queen again, since the pawn has moved two places from the current piece. So we should get two for queen now. So let's just try to run it once, and let's just see what we get it for the for the output. Like initially we should, I mean, first thing the test should pass, and the second thing is the when we are printing the board, initially the board should have queens and all the I mean all the pieces at their original positions, and when the pawn has moved, it should show that the pawn has moved two places, right? So let's see the output. So we have got the output. As you can see, the test passed. So that means initially it was empty, and when the pawn moved, we got two moves actually. And initially, as you can see output, pawns or the pieces were at original positions, and when the pawn moved two pieces further. And as you can see, one position is created over here, and one position is created over here for queen. So that's how you get two positions for queen over here, right? Great. So that's all I have created in this design. All right. I have created some classes in unit test, some basic unit test I have written. I have also taken you through how I've creating pawns and all, all different pieces. Now, let's see how my design is adhering to various design principles, right? So let's see first, like, single responsibility principle. So as you can see, each of the class is actually, doing only single responsibility, or is actually actually handling only single responsibility. So for example, board is handling only some stuff related to board. It is giving alternate adjacent cells which a board has access to. It's giving a cell at a particular location. It's checking player is on check or not. So this particular piece can be is debatable, right? Whether it should be a part of board or not. But right now, since as you can also understand, like a particular piece can be killed or not, or if a player is on check or not, is dependent on like board configuration, right? Dependent on what current board configuration you have, that will actually tell whether a particular piece is whether a particular player is on check or not, or whether a particular piece can be killed or not, right? So you can actually then argue, like, why not take out a board configuration object outside? That can be done. So we can have a board configuration separate, which will only have this thing, and then we can have a different class which is check player check player checker or something, right? Which will take a board configuration, and it will tell you whether player is on check or not. But that's like too complex, too much for the current design, because current design has these requirements only, so it fits over here. Like otherwise you can always create a new class for everything, right? But that's not the whole idea. The whole idea is, if this thing becomes complex tomorrow, then we can anytime take it out, outside, and we will not impact any of the other classes. So board is actually handling, is actually following single responsibility right now. Similarly, cell is only following single responsibility. It's adhering to, it's only handling what the cell is required to do. Piece is also doing what only a piece is required to do. So for example, it is doing moves. It is finding out next possible cells. A piece does not care about how does it move, right? So it does not have it really. The how does it move is actually handled by moves providers on various conditions, right? So the various conditions that you have put, that's actually giving piece a lot of flexibility, and thus making a piece a single responsibility, right? So piece is only handling what it is required for piece. Similarly, player is handling whatever is required for player, and it is made this method abstract. So whatever is required by a specific player can implement this method. Right? So move provider, again, it's handling only whatever move provider should handle, like what all different types of cells it can move to, and that's what it is providing. And different conditions, different checks, different move further conditions, cell occupy conditions are there in their separate classes. So each class here is doing single responsibility in a very good manner. Let's come to open close principle. So since it's following single responsibility in a very good manner, it's also following open close principle in a very good manner. So for example, each of the class that we are seeing, it's open for extension, and it's closed for modification. So for example, if a piece tomorrow it wants to handle one more type of move provider, so we'll just create one more move provider, and we'll just inject to it for that particular piece type. So it's extensible. It's an extensible design for piece. Piece can anytime start handling more move providers, but and it will not need modification, right? So it's like open for extension and closed for modification. Similarly, come tomorrow, if there is new type of move condition, or new type of base condition, you just create a new class for it, and you just hook it into the piece from the initialization. So your piece will again not get affected. There will not be any code changes in the piece class, so it is closed for modification. But again, if there is something new, it can be extended by creating a new base condition class, and it can be injected to it. So it's again extensible for open for extension. Now, let's come to interface segregation principle. So as you can see, I have created multiple interfaces, which is actually catering to specific type, a specific requirement. Actually, I could have created a single interface, which would have been, handling all the three conditions, but that would have, violated interface segregation principle. So over here, as you can see, each interface is actually segregated to handle single thing, right? So it's following interface segregation principle in a very good manner. Then you have, let's say, dependency inversion or dependency injection principle. Dependency inversion is the principal name, but it's very much related to dependency injection. So each of the classes, if you see, they take their dependencies from outside. So dependencies are injected in a very good manner. That the same thing actually give a lot of flexibility to the classes, since the dependencies are injected from outside. So you can anytime change those dependencies. So for example, if you want to create a piece of white color, you can just change the dependency. You can inject the white color from there. So you will get a white piece. So if we had defined only white over here, let's say, so it would have only created white color, right? White color piece. So you cannot reuse this piece for the black color. So that's what actually dependency injection means. So you are injecting your dependencies from outsides, and injecting dependencies also gives you a lot of flexibility. Like you can modify your piece class, modify the behavior of piece class by just changing the dependencies without actually touching the code of piece class. That's the beauty of injecting dependencies, right? Another thing which it is either into, like template pattern. So like move provider is defining a template for each of the move provider type. So it just define the template like you have to implement this method, this method, and each method will have to implement it. So it's having the template method also over here. Also, it is having that template method where it is defining template for each of the player. It is also actually going through or having the factory method where it's having a factory for cell occupy blockers. So different types of cell occupy blockers are being created for different types of use cases by the factory. So it's having factory method also. One more thing which I actually cared about a lot when creating the design is like immutability of different classes. So as you can see, most of the classes will have immutable properties. Like over here, board size and cells is immutable. You cannot change board size once it is initialized. That's what expected also, right? Once the board is created, you are not able to, you should not be able to change the board size. That's where the immutability comes into picture. Once the board size is initialized, it's not changed. So as you can see, board size is immutable, cells is immutable. Also, let's say in the piece, the properties which are required to be mutable are only mutable. Similarly, let's say a color is immutable. Once a piece is created for a different color, you cannot recolor it, right? So piece color is immutable. You cannot change the type of piece, right? So immutable properties are being created, and there is only one property which is mutable, which is the current cell. So since a piece can jump cells from one cell to another, so the current cell has to be mutable, and all the properties are immutable. How immutable is important is, immutable gives you a lot of confidence in when something wrong goes, right? So for example, if this thing is immutable, right, so you will always be sure the piece type is always what's going to be in at the initialization time, right? Whatever you pass it in the constructor, that's what it remains throughout. So but if you had a setter for it, then you will not be confident about it. So if you are debugging something, if something goes wrong, then you will have to check all the flows and everything, like if anything is calling piece type, set piece type or not. But here you will always be sure, once the piece is initialized, this value is never changed, right? But like current cell, we cannot make it immutable, since the current cell is mutable by its property, right? Like how does it work? So because piece has to move from one cell to another, so current cell has to be mutable. That's why we have to give a setter for it. Great. I hope you understand like immutability, and why immutability is important. It gives you a lot of confidence while debugging, or while validating something. So maybe you can read more about immutability online, but it's a very strong thing. It's a very important thing when you are designing, and you should always strive towards making your properties immutable, and make things mutable only when it is very much required. Another thing, you can actually see, like, I have put like non-null final checks at the at these places. I have put them only at this constructor now, but I should have placed it at all of the parameters, so that whenever I am using, let's say, player over here, I will be sure that the properties are not null. So this is again a very good way of coding, when you are doing something. Again, also defining properties final is a very important thing. This will again give you a confidence that once the color is input in the property, it will never be changed. Similarly, I should have actually created these properties as a non-null final. I did not create it, but that's one thing you should keep in mind when you are designing your classes and when you are actually writing your code. That's all from the current code point of view and what all designs does it follow. One thing I want to touch upon on is the future improvements, what you can do further in the current design, right? So for example, I have not implemented checkmate feature, so you can implement the checkmate feature. You will have to see how you will hook the checkmate feature into the game controller. So like, game controller will have to see after the player has moved whether the other player is on checkmate position or not, right? So at this layer you will have to check, or you have to introduce checkmate feature. So you will have to see how you can design checkmate feature in a very good manner. You can maybe write more unit tests. Let's say as I showed you, like, I have implemented only a very basic unit test, um, which tests a very basic flow. So you can maybe add more flows to it, and add more unit tests to it. You can actually implement that special move of pawn, where it can go diagonal also when it is allowed to kill, right? When it's actually kills, right? So that special move of pawn you can create over here, and you can inject it in the pawn piece. At many places actually you would have seen that we are doing OR operation and AND operation, right? So for example, in the cell blockers thing we were doing it. So in the cell moves provider, we were actually checking if any of the cell blockers is returning true, then return false. Uh, so basically you can definitely use OR property over here, right? So if OR of this blockers, then return false. So that's what I mean by this over here. Like, wherever we are doing OR or AND operation in the code, just try to generalize it by some or and design, and then this will actually improve the readability also, and your design also, and you will be able to reuse or operation and operate and end operation that you are doing in the code, right? So that's one further improvement that you can do. I'm not storing history of moves for each player, so you can also extend this design to do that. You can also add support for castling move, so that's a very interesting move which happens between king and a rook. So that's a move also you can add and hook it into king, because that's initiated by king. Also, as you can see, we have a reverse mapping between piece and current cell, and it's like, current cell also tells what's the current piece stored into it, and current piece also tells where it is stored. So this is like a double mapping that we are having. Can we remove it somehow? How about introducing of something like position, where you just store a position with a piece, and current cell will store a piece, and piece will not store current cell anymore. So that can be one way of doing it, but that's just one suggestion what I think we can approach it using. But the whole idea is, how do you think we can remove this reverse mapping? So what I would suggest you guys is, like, going through the video is one thing, but to understand the design better, to understand design concepts better, you really need to see how you can extend your current design, and that's where the further improvement enhancements come in. I could have easily, not easily actually, but I could have actually implemented some of these further enhancements in the design only, but I did not do it intentionally, so that you guys can try something on your own. You can try to extend this design, and what I would really love from you is, just change something, or improve the design, or improve these further enhancements, and then send me a PR, and I will be very happy to improve it and actually merge it in my code, and that will be helpful for you also, and for everyone who is watching this video, or who is trying to solve the chess problem. That's all from my side, I guess. I have covered up on what I have designed, why I made those choices, and what all design principles I have used. And one thing just I want to show you, like, like, what I've tried, I tried to make my design as much flexible as possible, so that tomorrow some new type of blocker comes in, let's say, or maybe move further condition comes in. Let's say tomorrow, today, the move further condition just says that you can move further only if it is free. But tomorrow there can be another condition where you can be allowed to jump your own pieces, but not the opponent's pieces. So you will have a new move further condition, which will just check that the cell's current piece should be either free, or cell's current piece should be of the same color as of the piece which is trying to move. So that can be a different move further condition. We'll just create new move further condition, and we will inject it from the piece when we are creating the piece, right? So that's how I have tried to made my design completely flexible, so that anything can be changed at any time without affecting the other classes. So if something related to move changes, you will change it at the move, you will edit something at the move. If some condition changes, you will add new condition, you will change existing condition, but nothing at piece and at unrelated class will not change. That's the whole idea of a good design. A good design always, it's follows solid principles, as much as possible, which I have also tried to do over here. Great. So that's all from my side. I hope you might have liked the video. You might have liked the code that I have designed. I hope that it will help you in your interviews that you are going to have in future. And if you really like the video and the design, then just subscribe to my channel, and like the video, and put a comment on it, like maybe a thumbs up, or good design or something, so that I will get some motivation for future videos. That's all. Thanks a lot for your time, and thanks a lot for watching this video. And yeah, see you in the next video. uh, till then, bye bye.